All right, good morning and welcome. Thank you for joining us today for our Thought Leadership webinar, Owning the Source of Truth, What Power BI and Fabric Really Mean for Your Business. I'm Simon, the Head of Marketing here at Zap. Just a couple of quick notes. Yes, we are recording and this replay will go out after the event. And if you do have any questions, please pop them in the Q&A and we'll tackle them at the end of the session. With that, I'll hand over to our CEO, Christopher Reeves. Chris, over to you, sir.
Thanks, Simon. And yes, hi, I'm Chris. I'm the CEO at Zap, and we like to get things done quickly here. So we do anticipate running this quite short, probably somewhere around 20 to 25 minutes. As usual, we've got a mixed technical and non-technical audience. So please spell things out if they fly past you, and that would be on me. You can hit them on the Q&A at the end, but let's get started. So we're here to talk Fabric, Power BI, and ERP, but we'll start with Fabric, and you'll see why shortly. If you've ever decoded Microsoft licensing, bring the same compass. Fabric will feel familiar. Fabric is a Swiss Army knife the size of a toolbox. Enough fun at Microsoft's expense, I'm going to make it simple. So broad strokes, Microsoft Fabric can be thought of in three blocks. There's store. Fabric provides a shared data lake storage layer, and we'll talk about what that means shortly. There's visualize, and you'll see why we started with Fabric. Power BI is a component of Fabric, and for the vast majority of Fabric customers, it is the end goal that you visualize in Power BI. And finally, build. Fabric provides a veritable tool shed of peripheral tools, not least SQL database in Fabric, data pipelines, and data science notebooks. So for this discussion, keep this in mind. Fabric is a platform. It stores data in a shared data lake. It's almost always used to visualize data in Power BI, which itself is a component of Fabric. And it has a very large collection of peripheral tools that enable that end goal. So based on the title of the webinar, you no doubt joined us because you also have ERP data. ERPs excel at data capture and control, but they're not optimized for data analysis, let alone AI. That's to say they are not optimized, they are capable of this. Power BI, on the other hand, is optimized for data analysis and visualization, and it is Microsoft's AI-ready front door. Quick note that Power BI is not a reporting tool. Again, you can report in Power BI, but it's not a native reporting tool. It could do a P&L table and do a very good job of P&L visuals, but it's just about unworkable for much more than a balance sheet, let alone a cash flow. Think of it like towing a boat with a mini. It can move, but it really fails when it matters on the ramp. So we'll talk about how reporting should be done in a little bit, but for now it's just worth noting that you would want reporting to be against your same trusted source of data. So for the most part, we'll keep the focus on Power BI visuals in particular, being that that's the intended outcome for most Fabric users. Now, it was only 2 slides ago, but very quickly, Fabric is composed of lake storage, Power BI, and some other things. You can see where we failed with ChatGPT image generation here. We went around a few times, and unfortunately, unstructured misspellings come precariously close to profanity. So we ended up getting this quirky result, and we're going to run with it. So we'll knock over the definition of a lake, and again, mixed audience, so I'm going to keep this pretty light, but we'll leverage the metaphor. A lake is the biggest occasionally man-made storage device known. So when nothing else fits, a lake is guaranteed to work. As a metaphor, lake storage also works quite nicely because it's rather obvious that there isn't a whole lot of structure going on in a lake. So when Microsoft designed their platform and needed a shared storage layer, they made the logical choice and chose what was guaranteed to work for any customer, excuse me, of any data size. The downside to such a logical one-size-fits-all choice is that the fit is usually pretty poor for most customers. Again, lakes are designed for massive storage and for structured and unstructured data. But we are here to talk ERP data and sources around an ERP, and ERP data usually fits on a modern phone, albeit maybe a big 1 terabyte iPhone 16, but it would fit. And it's also very structured, and neither of these are really what a lake was designed for. So there are two big issues using a lake deriving from the specialization of a lake for scale. So at the risk of stretching the metaphor, to transform any of your data or any of the contents of a lake, you need to move it out of the lake. And this involves a lot of additional plumbing cost. This is, for the tech folk, ETL. And secondly, without structure, lakes are unable to protect against duplicated data. We'll touch on that a little bit more, but I want to be clear, for the truly big data use cases, such as high volume machine data, IoT, data science use cases, lakes are the correct tool. For a lot of the intermediate space, they are not a bad tool. But for modest business use cases, which are a couple of hundred gigabytes, tens to a couple of hundreds, even low terabytes, they are a overkill and result in sacrificing data governance at the same time as paying more for transformations, which is really a net lose-lose. And we'll hit on alternatives. But first, let's contrast a lake with a warehouse. Again, leveraging metaphor. Key is that a warehouse is structured, so it's possible to protect against duplicate values. You just go to a shelf and you see if you've got the same thing in the same bucket twice. That same structure enables high performance transforms. You don't have to pipe data or contents out of the warehouse. It's a structured warehouse, so you can imagine you've got small robots moving around transforming your data in place. And so for the tech folk, now we're talking ELT, and this is dramatically more efficient, which means dramatically lower costs for data transform. But please don't miss the point on duplicates. Duplicated data is one of the highest risks to data integrity. It's why most databases for all time have, or as a feature, the ability to protect against duplicates. And so that was a big sacrifice given up in lakes to the end of scale. And we don't need it largely for business data. It happens, it's all too easy through data transforms, and even through errant data migration to produce these duplicates. And I'm not aware of a single CFO that would be comfortable with their opening and closing balances being duplicated. So we've got a feel for the metaphor. Stepping back, what's a data warehouse about? A data warehouse extracts data from your ERP and operational systems to create a single source of truth for reporting and analytics in your tool of choice. And for the topic at hand, a data warehouse should serve as the foundation for any enterprise-grade Power BI model. There's a fly in the soup here, and that is that Microsoft's Fabric data warehouse is based on lake storage. So the Fabric data warehouse doesn't actually enforce constraints that protect against duplicates. We'll talk about how the additional tools in Fabric can provide a solution for this. But for now, let me emphasize that Microsoft here is clearly called out. The heart of a BI platform is the data warehouse. And this is just one of many quotes that emphasize that Power BI demands a data warehouse. In the next 3 slides, we'll hit on our 3x3 governance framework before talking to performance and salad dressing. The salad dressing needs some explanation. The thinking is that you're already getting the wholesome calories from the first 2, and the additional capabilities earn the data warehouse a chef's kiss. So how does a data warehouse ensure governance? Data governance is fundamentally about trusting your data. For that, you need a single source, consistent naming, and common calculations all defined once. The data warehouse provides a central repository for just that. Moreover, by centralizing, you have one vault to secure for your green column and one vault to manage for compliance for your yellow column. But it's not just about centralization, it's also about enforcement. And a data warehouse, again, enforces constraints on your data. So no other component in the stack of analytics can do this. Above all, it's enforcing, again, that there are no duplicates slipping through when collecting or modeling data. As noted, Fabric doesn't provide this natively through their lake storage layer. So business critical data, such as ERP data, should land first in Fabric SQL database, which is a component within the stack that I alluded to. This can natively enforce uniqueness, and then it can be synchronized with the alternate lake storage. It is worth noting, because we had a question last night, is there an option that doesn't land in Fabric? And yes, you can use Azure SQL storage, which doesn't sync to the lake. So really your options are Fabric SQL database or Azure SQL database. One of them will sync your data to the lake. This is a second copy because the platform is synchronizing it. You don't need to worry about multiple sources of truth. The advantage in having your data synced to the lake is really that you could have, again, those downstream data science or large data scenarios. So I would say that it does end up being a significantly less common use case, but what you're really getting is one platform still. So there is that benefit from a licensing perspective. Now for blistering analytics in Power BI, you need a star schema. This is, if you're familiar with Power BI's documentation, littered throughout, very clear on the importance of having a well-designed star schema. Star schema is actually a structured data warehouse. It's a way of structuring your data warehouse. So that means every time you update this data warehouse, again, this is Microsoft reinforcing that need for a data warehouse, but every update then needs to update the star schema, and you need to do that efficiently. That in itself can be, particularly with ETL, a very expensive exercise. But a SQL database, be it in Azure or Fabric, uses the same structures we talked about before to accelerate these transforms by an order of magnitude. And again, these are the same structures that protect against duplicates. So you're getting a double benefit here. Moreover, the warehouse protects your ERP from heavy usage. So instead of hammering your source with massive data pools, it only grabs what's changed. So you will see in poorly designed setups that often an ERP crashes during month-end reporting when everyone's pulling data. Again, the data warehouse protects this. Finally, we've just added a few of the additional benefits here. There are some analytics which are simply not feasible without the performance benefits just discussed. A data warehouse can also retain data over time, which accommodates what's referred to as historical data analysis. For example, you can see here aging buckets over time. And finally, a data warehouse is significantly less memory hungry than reporting and analytic tools, so it naturally enables scale. So you've got the data warehouse ideally accelerated with a pre-built data model to get you there fast. And at this point, you're in a strong place. This is where Microsoft wants you. This is where you want to be. But I am going to leave a teaser that life can be better. Even with pre-built models, every ERP implementation is unique. You may have multiple company databases, custom fields, user-defined fields, analytical dimensions, currency conversions, and so on. This is where data warehouse automation comes in, and the right automation for your will ideally be designed for your particular ERP. If not, you'll be back to SQL joins for every custom field, etc., and life is too short for that. So, quick myth-busting interlude. Building an ERP data warehouse can't be that hard. Claim. Actually, getting a warehouse right is a niche intersection of technical and financial skills and the right tooling. So let me talk you through what you'll be signing up for if you opt for a do-it-yourself data warehouse. Firstly, with scale, you might think it's a few important tables. The reality is you'll be picking from hundreds of interlinked tables and potentially billions of rows. And we do have customers with billions of rows. Complexity, product documentation aside, each implementation is a unique Gordian knot of undocumented workarounds and business decisions. Processes might seem simple until you hit credits, reversals, split payments, and period straddling surprises. Transaction date versus posting date means decisions could mean nothing reconciles. Data quality can't be assumed with ERP systems because manual entries and reversals happen. Expertise is spread across multiple team members, meaning IT waits for the finance team at the end of every month. And the reality is most of the reporting usually ends up being owned by the data team, and that's what nobody wanted. You might think, hell, I'll go back to Power BI direct to the source and skip the data warehouse then. But the thing is, these same steps should apply to any trustworthy Power BI model. It's the stand-up ease of Power BI that means that these details are so often missed. So a data warehouse doesn't end up creating new work so much as forcing you to have done the right work. Moreover, many tools come with a pre-built model that provides the foundation for your custom warehouse, alleviating many of the challenges above. Just one more thing on automation. You want to be sure that every time you add a column in your data warehouse, it's automatically picked up in Power BI. And every time you refresh the data warehouse, the Power BI refresh waits until the warehouse refresh is complete. If it doesn't wait, you'll be picking up partial data. And partial data is wrong data. Midway through a transform, the data will be wrong. So this is essential. You must synchronize Power BI with the warehouse. So your options here are to manage the synchronization yourself, ideally not manually, but through integration tools and APIs, or you can start with a tool that natively synchronizes a data warehouse with Power BI. And there are very few. The Microsoft stack sensibly is one of those offerings. So very quickly, if I've sold you on the importance of a data warehouse, what are your options? Now, if you're on Microsoft ERPs, Microsoft provides Power BI templates at varying levels of productization. These templates can't be modified. Rather, they need to be copied and then configured from there if you wanted any tweaks. So they are quite rigid. They have data refresh and storage limits. Templates are one size fits all effectively. I do recommend that you try them for where applicable. And if they fit perfectly, just go for it. But don't expect them to grow with your business. And then as soon as you move beyond the rigid bounds of a template solution, you need to consider Microsoft's sync methods. sync to Lake or Fabric, etc. These give you a leg up on the data extraction, but you're still left building the entire warehouse. So that's extraction, is to say they get the data out, but there's no structure as such other than the original source structure. And all the DIY challenges previously described still apply. Now, if you're on a non-Microsoft ERP, Sage is for SAP or more, there are vendor-provided connectors, third-party connectors, and native SQL options that Power BI can connect to directly. But at this point, I trust that you're convinced on the data warehouse. So one option then is to use these connectors or native SQL options and Fabric data pipelines to pipe your data into a Fabric SQL database, as we touched on. So again, from here, you'll be left with all the DIY challenges previously discussed. So it does, you might note, end up appearing, or it is the case, that whether you're on a Microsoft or a non-Microsoft ERP, as soon as you get out of the rigid template solutions, you're in pretty much the same position. And this might seem surprising that being on a Microsoft ERP doesn't provide a bigger leg up. But keep in mind, Microsoft provides the platform and they expect partners and services to build on top. And that is the ecosystem play of Microsoft. So this is now exactly where Zap fits. Zap automates the data warehouse on Azure or Fabric. We enforce integrity, generate the star schema in the data warehouse, handle the pipelines and history, and we sync with Power BI. Fabric supplies the platform. Zap productizes the ERP to analytics pathway. And we typically deliver a 60 to 80% reduction in time to value and total cost of ownership through our automation. To put that in context, we've had customers come to us after spending $500,000 on an unsuccessful data warehouse project. That is $500,000 USD, and we had them live in months. Let's keep moving. We've just had a few more slides. Power BI isn't for everyone, and it's not a natural fit for the finance team. So let's see how Excel fits in around this. Now, I've spent too many years being wrong on this particular point, but Excel is not the enemy. It's just another BI tool, and it happens to be the world's most popular. So we are very much leaning into Excel. Very much you might challenge my claim that it's a BI tool. However, if you have the right foundation, Excel is indeed BI, or at least hopefully you would grant me BI-esque. By driving Excel from the Power BI analytic layer, in turn, based on a data warehouse, you have the performance to slice and discover as with true BI. And you have confidence of numbers you can trust in. However, the larger challenge with Excel has always been formula anarchy, and Power BI can address this by serving as the metric store, ensuring again there is that one definition of net profit or day sales outstanding, or whatever key number drives your business. So the net is that Power BI and Excel are natural complements. Getting around to AI, and it's very unlikely that you're ready, or more correctly, that your data is ready. KPMG agrees, or more to the point, I'm leveraging their data, but their claim is that only 85% of people feel that their data isn't ready. However, this is self-reporting, and as we know, who would trust self-reporting? Who would trust a self-reporting study on IQ or height? The other 15% of companies here, I'd say, are very simply not admitting to their problem. Again, very few companies have this right. Now, this is a discussion on Fabric, so we'll go through AI quickly, but what would it take to get AI right? Firstly, you'd want governance for data you can trust. Then you'd want structure for performance and native enforcement of your data integrity rules. Again, reinforcing your governance. And finally, you would want context. And that means all your business data, your ERP data, CRM, inventory, and more in one place with rich names. Once it's in one place, it's a lot easier to invest in those rich names once, and rich descriptions, and even AI overlay of instructions. Suffice to say, this is what a well-considered data warehouse provides. So a data warehouse is and should be the first step in preparing your data for AI. So when don't you need a data warehouse? And short of the tongue-in-cheek responses here, there are two legitimate cases where you might not need one. Firstly, if you're building out a proof of concept model, it makes sense in Power BI to just hit the source as long as it's off down hours. Or if you're rolling out a new ERP, again, which is essentially you're building out the proof of concept. If you're in a transitional project state, essentially. For everyone else, it's probably time that you follow Microsoft's guidance, our guidance, and source your Power BI model from a data warehouse. All that said, let's hit on the core. And that is that Fabric is a platform you must build on and govern. Zap is a product that runs inside Fabric or Azure to deliver dramatically faster time to value and lower TCO, total cost of ownership, sorry. And we stake ourselves on performance with our advanced ELT and proprietary delta processing, enabling sub-minute refreshes on nearly any ERP data set. So please feel free to reach out and see these results for yourself. With that said, any questions?
Thank you, Chris. We do have one question sitting in the queue. How does Zap compare to business performance analytics?
So business performance analytics is, as much as it seems like, it is a product, but to be sure, it is one of those template offerings. So again, it's an example where it's quite rigid in that you get, for example, I think it's 2 refreshes a day and 8 quarters of data, but it's also more that the entities that are connected to can't be modeled or configured. So if it works for you, again, that's if it fits, use it and consider, but otherwise, and consider that it may not, or you may grow out of it.
And Chris, that's the end of the questions. So thank everybody for coming and attending the live session.
Thank you all.
Recording coming up tomorrow. Thank you very much.
Breakfast time. Cheers.